Hello YouTube, this is Frank, and this is Friday, September the 25th, 2020, and this is my 42nd video and my third text editor video. And I was going to talk about TDE 5.1v, and last week, or last time I left it, so this week I'm going to expand those macros in the memory.c file and give the user a choice of memory managers. There's our TDE 5.1v, and the file folder, I'm going to put these on my Google Drive, and that's the file folder that goes with this video, TDE 3, choose the memory manager, and I expanded the macros in memory.c and give the user a choice on memory managers. And also I'm going to be using some style in all of my changes. It's been about 30 years since TDE since I wrote TDE, and Doug wrote DTE, and the reason I'm going to expand the macros, Google has a style guide, and they say to avoid function like macros, and certainly when I was debugging TDE 5.1v in a 64-bit environment, it was very difficult to see exactly what the code was doing. So I'm going to expand the macros, and also that's the Carnegie Mellon University. They have a site where they have a style guide, and I am going to avoid implicit block begin and end, and just search for CMU, Confluence, exp19.c, and I still want to issue a warning. I would not use TDE 5.1v that we're working on. I would not use that in a production environment. There are some things that we need to fix or modify before I would. Now, for personal use, I would go ahead and use it for personal use, but I would not use it for. I would not let anybody in the production environment use that. Now, this is Windows 10, and I think the last time I was using, well, this is VirtualBox. I've got several different virtual machines here in Oracle's virtual machine, VirtualBox, and this week I'm going to be using OpenSUSE 15, and that is the 64-bit operating system. So over here I've got my SUSE. Let's see. Now I usually do my operating system. What's my operating systems? OS. There's my operating system information. OpenSUSE Leap 15.1. And I usually do my uname. -A. And there's 64-bit Linux, and then I usually do my print out the GCC version that the system is using, and that's GCC 7.41. So let's see what we got here. Oops, before I get started, now 30 years ago, I learned C from the that original C programming language book. Dennis Ritchie was the developer of C. And I'll be using. There's a we've got all kind of guides on secure coding, but I'm going to be referencing secure coding in C and C++ by Robert Secord. Now when we look at that memory manager, if you are interested in more information on the memory manager, Donald Knuth has a section in his book, in the Art of Computer Programming, Volume 1. Alright, so let's see what we got here. Those are all the files from that original TDE 5.1, and you can see now the only ones that I modified was regex.c. I just got rid of some compiler warnings. I didn't do very much. TDE structure.h. Let's see. Let's go over here. That file right there, and let's see here now. This is the top of the file. If we were to go down to line around 540. Let's see, we need to get down a little further. Yeah, right here, that was the original memory manager structure def right there. Now I changed that to explicitly use int 8 type for the pointers to the 8-bit or the 8-bit blocks, bytes in there. Unsigned int 32, and same thing for that free pointers, integer 8. Just a 1-byte sign, and those are signed integers. Those are like signed characters. I put the exact size and the exact type that I want for that memory structure. So let's go over here. So what we got? That was that. Modifying that make file. Now let's look at that memory.c file. That's the one that I made a lot of changes in. It's the top of this file. Left all of Jason's original comments, and these are my comments from September the 13th. That was the weekend before last. I expanded those macros. It was when I was debugging the memory manager in the 64-bit environment, it was very difficult to follow that code with macros. Then I used those standard integer fixed width types. So now the TDE 5.1v, it works in 32 or 64-bit environments in Linux. A little change there for the pointer types. That's some residue from back when I was doing some DOS programming. So that's like 30 years ago. But anyway, if we want to use a pointer, we really need to use an unsigned integer pointer type, and that's in that header file. And now we give the user a choice in this file, the memory.c file, to choose between Jason's memory manager or the C library memory manager. And somebody may want to use the default library manager. If the CPU does not support aligned or unaligned memory access, or the compiler may not support misaligned memory access. If you turn on the vectorization switch in an optimizing compiler, it may complain. And then the user may just prefer a memory, the default C memory manager, because in those things nowadays that has checksums. Some of them, they segregate the data and the metadata, and they randomize allocations. So either the CPU, the compiler, or the user, depending on what the user wants. And this is kind of an overview of Jason's memory manager. It starts out with that -1 there in the first byte, and then the pointer to the next memory block, and then the pointer to the previous block, and then the length of that of the current block here. Now I added there's that fixed width type. Instead of a character, I made it a signed integer, because we want to go back and forth between the memory, and then characters are it should be able to store characters. And these pointers here are 16 bits, so that's where the 16-bit type comes from. And those are unsigned types there. And when you debug it, you'll see that's the low bit and the high bit, and these may be unaligned. They often are. It starts out being unaligned, but as long as we tell it, give it the fixed width type, we should not have any problem there. If the CPU supports it, and if the compiler supports it. Let's see here now. There's that pointer to unsigned long. That was way back in the DOS days. Anyway, here's that if right here. If you want to use Jason's memory manager, just set that to 1. If you want to use the C library manager, set that to 0. It should compile either way. Well, it does compile either way. So let's go down here. And you can see I changed all of those pointers. Let me get back. Well, if it's a pointer into that memory block, it's assigned that, I redefined that as an 8-bit integer type, signed integer type. And if it's looking at the size of the space of those blocks, I made that an unsigned 32-bit type. And we saw that on that TDE structure back there. Let's see here. And these are the macros. I expanded the macros, so when I go through here and try to debug the memory manager, I can see exactly what the code is. The macros are not hiding the code. And let's see if we go down here a little bit more. I expanded these. There are no implicit begin and end blocks. In C, you can, it's optional, you can leave out those braces, but in my style, starting in 2020, all blocks will have explicit begin and end braces. No, there's some more right here. No implicit braces. All right, so that's the changes that I made. We can't just to be. There's the original code right here. Let me just show you that right there, right quickly. There's memory.c right there. Let's go over here to the top. Oops. Let's slide up to the top. This is Jason's original thing, original code. And these are those macros that I expanded. I expanded all the macros so I can see exactly what the code is doing. There we go. There's some implied begin and ending blocks. I explicitly put a brace, beginning brace and an ending brace. Beginning brace and an ending brace. Beginning brace and an ending brace. No implicit begin and end. There I would have another beginning. This is in 2020. This will be my style. I'll be using the Google style guide. Here's the Google style. Oops, let me just get out of this one. The Google style guide. Just search for Google style guide, and here it is. And that's a community Creative Commons license, so we can display that. It's copyrighted, but they allow you to display or to show the guide. And this is the guide from Google for the C++, and I will be using this, the Google style guide. So Google, they have millions of lines of code and thousands of engineers, and so they want a style guide for their company. And I'll be using Google style guide and the Carnegie Mellon secure coding style guide. Going forward, this is 2020. It's time to update that code. But then let's just compile what I got here. Oops, let me just. Okay, there's our. Let's make. This will compile. TDE, so we can run it. And there's TDE. Looks like those old MS-DOS programs from 30 years ago. Now, I am running this. Now we did fix the that loop, that infinite loop. Now we need to look again. And in OpenSUSE, there's that their system monitor. Now if we look over here at the system monitor, TDE is using 25% of the CPU, and I've got 4 CPUs on this virtual machine. Now a simple text editor should not be using 25% of the CPU. And so next time we will see if we can figure out what the problem is there and fix it. So that's what there's the TDE 5.1. That's what I did this past couple of weeks. So thank you for watching, and we'll just continue with TDE 5.1. Thank you. I'm gonna put that on my. I'm gonna put the code. Let me get back up. Let me get out of here. Oops. Now this is that directory. I've got this code. And I'm going to put all of my the code here on my Google Drive in case anybody is interested in the improvements that we've made in TDE. So thank you for watching.